So first of all, I want to apologize. I didn't mean to keep any of you waiting. I decided to take a cab ride over to the Caesars Forum. I told the Caesars Forum to the cab driver. I didn't know exactly where the forum was. I ended up across the street about a mile away and did a sprint job over here. So if I look sweaty and I look disheveled, that is because I'm horribly out of shape and probably could use a little bit more exercise in my life. But first of all, I wanted to also apologize to our guest, Pandyan. It was, we're really happy to have him today to talk about the solution he's building with MedHost. And just to kind of quickly introduce myself, my name is Sid Rao. I'm the general manager of the Amazon Chime SDK. So today in this session, we're going to talk about how we can enable scalable communications across many different use cases, from application to person services to asynchronous chat to real-time audio and video and telephony services. And what's something going on? Can you hear me now? Okay, great. To discover many new innovations and capabilities that AWS has delivered in the communication space, specifically around email, SMS, push notifications, audio, video, public telephone network services, and how these services can be put together to create unique customer experiences for your customers or other stakeholders within your organization. So, I first want to kind of take a moment and explain how we've come to this moment where we have communication services from AWS and some of the more compelling events that have driven us there. A couple of years ago, we had a minor health concern called the coronavirus pandemic. It really had a major impact in terms of how organizations had to transform the way they communicated with their customers and their stakeholders. Overnight, folks had to change the way they did many common activities throughout their household, throughout business, from purchasing groceries to visiting the doctor. Common activities that were basically, focused around human person-to-person type interactions had to move to virtual interactions. And it starts out with maybe an asynchronous channel such as SMS or a notification of an upcoming appointment or some mechanism to engage that particular customer. And then it rapidly escalates into a real-time audio and video service where you have a very deep or collaborative engagement with that particular customer. Video became a very common mechanism for meeting customers. Our customers started to routinely report that their users were very comfortable with joining via video. They were very comfortable going to the doctor via video call now, or engaging via text messaging or chat with a nurse or a care team in the form of telemedicine. Making decisions about how to talk to drivers via text messaging so that deliveries could be coordinated to their particular household or to their particular business. So we saw a very strong enablement of these real-time and asynchronous communication channels, and the stats basically kind of tell the story here. Literally overnight, for the Amazon Chime SDK, we saw a 17 to 20 times increase in the number of peak concurrent audio and video sessions that we were handling on our particular platform. So it was a massive scaling event. It was a global scaling event. And AWS had to deliver a number of innovations to respond to that particular compelling event. And we've continued to do so as audio and video and text messaging and other forms of communication have become just very common, all the way down to across multiple generations and multiple different types of internet access and what kind of capacities they have in terms of last mile. We're still seeing that behavior of moving towards video sessions. But this wasn't just some kind of a one-time, mythical overnight transformation that occurred. Let's just tell a few customer stories based on the numbers that actually were involved here. As I said, year over year, we saw a 784% increase in video sessions on the Amazon Chime SDK. Just for Slack alone, we power 2.5 billion minutes of audio and video every month. We enabled Blackboard with the virtual classroom of the future, or the modern classroom of the future. And it serves about 150 million daily active users across 80 countries, Pinpoint, from a perspective of messaging, in 2021, year to date, we've sent 230 billion messages. And SES in a given year sends 500 billion emails to users or to customers, and as an engagement or notification or collaboration function. So we served a number of different customers. I personally worked with a number of these customers, as they had to build their remote engagement and collaboration story, whether it was a Slack or a Salesforce, to a Blackboard for online learning, to Mitel for collaboration purposes in a more traditional telephony perspective, Mindbody from an athletic and online online training and exercise platform and regime. So as we started to think about these particular services, we've now started to categorize them as a category, communication developer services. There are three fundamental services that fulfill this particular category: simple email services, the Amazon Chime SDK, Pinpoint, and in a nutshell, customers use these services together to create a comprehensive communication experience for their particular user. We rarely find that a customer is satisfied with simply, turning on real-time audio and video without having a way to notify users of an upcoming appointment via an SMS text message sent via Pinpoint, or a summary of the visit sent via SES. So these services often have to be used together to enable comprehensive, complete end-to-end communication flows and power workflows within the enterprise. So in today's session, we'll learn how to enable these secure, scalable communication capabilities in your apps and services. We'll cover application to person, asynchronous, real-time communication workloads. We'll basically explore what kind of communication capabilities are builders building, and how are they using these services in concert with each other to get there. So the Amazon Chime SDK launched at reInvent 2019, so about 2 years ago. It was built, while it shares a name with the Amazon Chime app, it was built basically on the learnings and experience that we had in developing the Amazon Chime application. It works independently of the Amazon Chime application. There is actually no real shared concepts of identity or security model or anything of that sort between the application and the SDK. And that's because they serve two very different constituencies. The SDK serves application developers, independent software developers, enterprise developers building communication capabilities into their application, whereas the Amazon Chime app serves traditional enterprise collaboration needs, right? So chat or holding a work meeting via video. So two very different types of constituencies and customer workloads that we're targeting. And therefore, while they share a name because they share a common heritage, they now have gone in two completely different paths with two different roadmaps that are associated with it. The reason why we built the Amazon Chime SDK was because customers told us that building real-time applications was challenging. It's inherently difficult. There are multiple protocols involved, multiple standards compliance across browsers or the public telephone network or in global environments is different. Hosting global infrastructure on a pay-as-you-go and efficient model is not easy as well. Like most things in the communication space, you can usually host simple audio video services by, hosting a couple of WebRTC turn servers on AWS. You certainly can get started there. But when you try to build applications at scale and you try to handle that undifferentiated heavy lifting that's associated with making sure audio and video passes across the internet in the most efficient way, that's where AWS steps in and basically adds value. We take away that challenge of hosting that infrastructure and making it automatically scale, having it handle some of the complexity that's associated with these WebRTC sessions or the public telephone network. Another area that we focus on is lossy and turbulent network conditions and how to mitigate those and handle a variable last mile that we have between our service and the customer. We use a variety of techniques, from traditional network techniques by integrating with CloudFront and using CloudFront POPs for, basically handling that last mile of session, audio-video session, all the way to applying machine learning for problems like packet loss concealment, removing echo, removing background noise, helping customers do image segmentation to blur backgrounds so that you can focus on the human being, the human voice, or the actual face that's involved. So we basically put together a complete end-to-end, customer experience-focused SDK where customers can mitigate lossy network conditions, mitigate some of the complexity associated with delivering audio and video sessions over these complex environments. So a good example of that actually is what we've done basically in speech enablement. So the Amazon Chime SDK has a fundamental subservice that's focused around basically audio enhancement and improving the fidelity of audio sessions. One of the most common requirements, especially as we've all worked from home or we're taking doctors, visits from home, is the ability to get rid of those barking dogs or mowing lawnmowers that are in the background. And the traditional approach that audio engineers used to do is apply traditional signal processing to remove that particular background reverberation or hum from an audio signal. Well, we took a very different approach to this problem. We actually used machine learning to basically focus on the human voice, extract the human voice from that audio signal as it passes from a browser or a mobile application or some sort of a WebRTC endpoint, and basically render only the human voice to particular customers. So let's just take a quick example of what that sounds like.
This is an example of talking and typing at the same time, which I find very challenging.
So that was Mike. Mike Goodwin, he's a scientist on the team. He just basically gave us a simple typing example. Background noise in that case is the clickety-clack of a keyboard.
This is an example of talking and typing at the same time, which I find very challenging.
So as you can see, we basically cleaned out that background, that background keyboard clicking, and basically focused on the human voice, pulled out that particular human aspect, and we did that by training a series of neural networks on just focusing on the human voice. And that machine learning workload runs in a combination of both on-prem in your browser environment, as you can run in a browser, or it can run in the cloud. And we choose, based upon the type of workload, whether we're going to extract that human voice in the browser or within the cloud as we send that audio signal between two different parties or between multiple parties in a collaboration session. So we continue to basically evolve the platform across three different pillars. So the three pillars that we focus on are basically media services, which are the audio and video sessions. So the ability to host a multi-party audio conference, be able to basically, have somebody join via video for a remote banking scenario, for example. The second place that we focus is on the messaging services. And with messaging, let me be clear, that's chat. So the ability for 1 to 100 to 1,000 folks to basically chat in a collaborative chat room. These are often done for a variety of use cases, whether it's a conference like reInvent, or it's just a chat between two different parties that, for a banking visit or a telemedicine visit. Oftentimes, persistence is a requirement of that messaging platform so that you can, for example, retrieve the message history between a doctor and a patient, or a care team like a nurse, doctor, and pharmacist, and a patient over a long period of time. The third area that we focus the Amazon Chime SDK on is public telephone network services. So again, all three of these have to be often used in combination with each other. You may start a chat conversation with your doctor that's focused on, I'm not feeling good, or doctor, I ran across from Caesars Forum from Caesars Hotel to Caesars Forum, and I'm having significant amounts of pain in my legs right now. And basically, you might start off with a chat message like that, but then he might indicate that you need to call the nurse, so you pick up the phone and call the nurse via a traditional public telephone network call, and then you may escalate to an actual audio-video session with your doctor where he has a chance to inspect your symptoms and understand how are you progressing. So that's a very simple use case where all three of these capabilities have to be used in conjunction with each other to create a comprehensive communication experience for customers. So we go, a great example of this is what we've done actually with Slack. So Slack today powers basically millions of people to align their teams. About over 750 organizations use Slack. They send 1 billion messages a week and are growing. Overall, we've basically in 2020 we started a partnership with Slack where they use the Amazon Chime SDK to power their audio and video workloads. Prior to that, they were hosting all of their infrastructure on EC2. So like I described before, they were hosting, servers to redistribute audio, to transcribe audio, to, mix audio together, provide video services. It was a ton of services and infrastructure they were hosting on their own. They saw an opportunity to pass that undifferentiated heavy lift to AWS. We now took that over. We do about 2.4 billion a month. But we went beyond just simply doing audio processing for Slack. One of the things that we also enabled earlier this year was the ability to automatically transcribe this audio to provide a real-time caption stream of what's going on in a particular Slack conversation. They took that capability and built a service called Slack Huddles. And Slack Huddles is a very popular feature that basically has started to grow quite a bit for Slack, and it allows people to basically drop in on a work conversation, step away and just simply get a transcript of what's going on while they were stepping away. And it allows them to basically have a very virtual audio space where they can collaborate in real time, perform content sharing. And as they've described recently, they're starting to take this to video. They use our science to suppress background noise, so it's a very clear audio signal. And they've started to, consider other capabilities and how they can engage Slack outside of Slack workspaces for these audio and video sessions. So Slack Huddles, super cool use case where they use all of the capabilities of the SDK. Recording is an additional capability. They've started to basically invest in to capture that audio, optionally capture that audio if customers have use cases for archiving that or associating with that with a channel. So, this is just an end-to-end example of how the SDK gets used by a pretty large independent software vendor. So, with that, I'm going to switch to the second service I was describing, which was Amazon Pinpoint. Amazon Pinpoint makes customer engagement flexible. It helps you reach the right person with the right message. So you're able to send very targeted messaging to target audiences. And one of the key capabilities of Pinpoint is the ability to leverage, the core capabilities of AWS: reliability, scale, and security. Pinpoint supports multiple different channels, such as SMS, push, voice notifications over the public telephone network, email, and basically Pinpoint, scales to billions of messages per day. Now, you can use Pinpoint in multiple different capabilities. You can use it at a core capability to basically target folks in a marketing style function, or you can use some of the underlying capabilities to just send bidirectional SMS. We have customers that use the Pinpoint APIs all the way to Pinpoint as a turnkey marketing end-to-end service. In 2021, we further invested in these SMS capabilities, engagement and orchestration capabilities as well, and we introduced new channels. We launched 10-digit long code support and toll-free numbers to basically support U.S. carrier requirements that are associated with that. We also provide a sandbox now where customers can basically experiment and do test and dev work basically related to SMS. And it also gives us a mechanism to help customers with fraud and abuse that's associated with that sandbox mechanism. Pinpoint, out of the box, provides one-time password mechanisms. Very useful for authentication flows, the ability to verify, that you've actually got the right intended person behind a very sensitive flow, such as a password reset. And customers don't have to build any kind of a custom solution to basically create these one-time password style flows. So one of the things that I really enjoy about Pinpoint is that as a developer, I can use, just very direct SMS APIs that are bidirectional in nature. I can actually integrate that with the chat capabilities, for example, in the Amazon Chime SDK, and have a bidirectional collaborative session. I can then use some of these packaged capabilities, such as one-time passcodes, to power the password resets or notification needs that I have. So like appointment reminders, email resets, things of the nature are available to me as another layer of APIs. But then I can also use it in a marketing function to do broad-based marketing and keep actually that audience in the same audience I'm doing, one-time password changes with. That same audience can be used for marketing or app notification or in-app notifications that are commonly required as part of developing a mobile application or a web-based application. So a great example of that is what we did with the Provincial Health Services Authority. Basically, it's a publicly funded health service provider in the province of British Columbia. PHSA has a unique role in British Columbia's health authority. They ensure that the residents of British Columbia have access to coordinated provincial network of high-quality, specialized healthcare services and programs. They basically, the PHSA works in partnership with the province's health authorities and healthcare professionals to improve access to evidence-informed practice closer to where people live, and to effectively promote health, manage chronic conditions, and reduce the burden of illness. So when you look at the Provincial Health Services Authority, their needs across Pinpoint, they had all the needs from standard things like appointment reminders to the ability to actually do targeted notifications for to specific patients or particular residents of that particular locale, all the way to your traditional broad-based notification that's associated with having 50 million people that you have to send vaccination-related SMS messages to basically let them know a vaccine is available. They can sign up for a COVID vaccine. When can they sign up for? When can they engage to get themselves vaccinated? So, basically, it's a one-stop shop for everything from notifications all the way to just the raw ability to communicate through these channels, whether it's in sending a mobile push notification or an SMS notification. So, moving on to Amazon's SES, Simple Email Service. Basically, Simple Email Service, is a very highly scalable mail relay and mail distribution mechanism with the security mechanisms that we typically like to see with email, whether it's fraud detection, the ability to actually, detect when there's a security problem, malware through attachment scanning. They're all capabilities that can be layered on top of SES. And so therefore, you have a very scalable email delivery platform that also can be used by digital marketers or application developers to send application-to-person style notification and transactional emails. So whether this is telling you that, whether you're getting an email from Amazon.com saying your order is being delivered, to a password reset notification, to broad-based marketing, SES basically powers this very standard asynchronous channel that's typically required by most app developers in a communication workflow. We've been one of the largest global email providers around. We've been doing this for about 10 years. We do about billions of emails per day for our customers. And SES has basically continues to be a critical part of usually the start of a customer communication or a conversation with a particular customer. So, in 2021, we basically added a number of features, whether it's, the ability to do configuration on configuration related to an email identity, to a particular, domain, configure specific handling policies for specific email addresses. We basically, can handle a whole variety of metrics that are associated with that are, on how to handle opens, clicks, send, deliveries, bounce-ins, and complaints and things of that nature. There's also additional abilities to help diagnose faults related to, bounce backs and things of that nature. Basically allows you to, have a better shot at understanding why certain marketing campaigns and email functions are not necessarily working related to email. So SES continues to be a feature a service we continue to invest in, and we've continued to make progress in terms of incremental features. And again, it's used just like the SDK and Pinpoint. You have the ability to use it at a very low level, just as a raw mail relay, or the ability to send and receive messages, or as part of Pinpoint in a more integrated marketing effort that's related to your particular customer. So in the case of Netflix is a great example of actually how they use SES. World's largest and leading internet television network, 150 million members in 190 countries, and basically, the Netflix messaging team uses SES to basically handle all of their notifications and how they communicate with members via email. SES is the primary mail relay that's used by Netflix, and prior to SES, Netflix used to actually host their own internal fleet of mail relays. And hosting mail relays at first sounds very easy, just like we described for the SDK. It's easy to host turn services or WebRTC infrastructure at first, but making that scale, making that handle the complexity and volume and handle the spiky nature of customer communications is quite challenging. So prior to SES, Netflix used to manage their entire own fleet of mail relays. They got a significant amount of efficiency by moving that to SES, and they got rid of a bunch of operational overhead. They didn't have dedicated servers. They didn't have to worry about scaling up and scaling down. In terms of their mail delivery, issues like runaway mail delivery queues and things of that nature went away, and they were able to rely upon SES to just basically again handle that undifferentiated heavy lifting. Now, in summary about these three different services, as you may see, these can be used to get in combination with each other. And they can be used at multiple different layers. If you want to use it at a low-level primitive to send and receive an email, start and receive an audio and video session, you can use SES for the email. You can use the SDK for starting and creating that audio-video session. But you can go up get increasingly a lot more complete components that basically application developers can use to enable more complete experiences within their app. So in the SDK, we produce a set of React components, for example, that enable a customer to easily create multi-party audio and video sessions within a browser with just around 100 lines of React code. And then if you look at within, for example, Pinpoint, we provide the ability to actually do one-time passwords, a very common application developer need, again, handled by a few set of APIs. And then we, of course, provide overall broader marketing distribution mechanisms through Pinpoint. We provide broader solutions around the public telephone network and the ability to provide everything from corporate telephone services all the way to interactive voice response or conversational telephone calls basically across the Amazon Chime SDK. So you can start at the lowest level or use larger components from the SDK, Pinpoint, or SES to deliver an end-to-end communication experience. And with that, I'd like to introduce Pendient, who's going to basically walk us through basically how MedHost will be leveraging these components and SDKs to basically deliver an integrated healthcare experience. All right, thanks.
Thanks, Sid. Good evening, everyone. I'm Pandian Velayudham. Go on to the next slide. I would like to take a few minutes to talk about how Medhost is using AWS services to implement secure communication for our customers. So let me skip this agenda and move to the about Medhost. So Medhost has been in a EHR market for more than 35 years. We have been providing services for our customers, all type of customers, the hospitals, full service hospitals, step-down hospitals, post-acute care, and emergency. So moving on to the next one. So before we start talking about communication or messaging platform, I had to visit hospital a couple of times last year and this year. And I noticed a lot of differences with respect to process and procedures. But some of the things have not changed much. If you can see that providers are still using electronic health records. That's a good thing. So they are using electronic data that gets stored. But they are still using paper, pen, sticky notes, and fax still within the hospital to communicate between departments. They still use fax. It's not just outside of the hospital to the inside the hospital. It's just within the hospital. And then we still see pages are used in some of the emergency department. Intercom is used very much, voice messages. Still they walk to another room to deliver some of the messages which needs to be communicated. What is the problem because of this from the provider side, hospital side, and patient side? So you can imagine that this creates a delayed patient care. That would lead to a longer stay within the hospital. So there is a possibility that this patient history can be missed. If that patient history is missed, that can create operational inefficiency. The operational inefficiency can lead to a provider burnout. So most importantly, missed communication to families. These are all the problems we see currently within the hospital. So why do we need a secure communication? We can look at this from the two perspectives. One is from patient perspective, another one is from the provider perspective. If we have a better secure communication, we believe that it can improve the patient care. And also it can improve the family communication. How many times we have been to hospital and came out with the feeling that we have not got enough information from the hospital, right? And we can reduce the length of stay by improving a communication. From the hospital side, even though we build applications for particular clinical workflow, every hospital has their own policies and procedures. Based on the policies and procedures, they are going to use our system little different. For that difference, what they are going to use, they are going to bring in some manual process. Like I said, paper, fax, or some of the things they are going to bring it. So what does that mean? They have to stop at certain point and move to the different tool and come back and continue once they have that information. What if we can solve the problem with integrating messaging within the application itself? That can improve the clinical workflow. If that gets improved, you can see that will lead to increased operational efficiency. So other reason, because this information is still with the paper and pen, we lose a lot of health record information. If we can digitize that, even though it's unstructured data, using AI and ML, we can extract information from that unstructured data and store that as part of health record. That would certainly improve that patient health information. That improvement will help to reduce provider burnout. What does that mean? Provider need not spend a lot of time in front of computer. Instead, they can spend quality time with the patient. So how do we see this as a communication solution? You can see here, provider and patient here. The communication is not only from between the provider and patient. Provider interacts with multiple systems, and patient interacts with multiple systems as well. Patient can set up an appointment. Patient can have their own health device, which generates a lot of data, which goes into this health records. So apart from these two actors, the patient can go back home, so they are outside of the hospital, not inside the hospital anymore. So we need to continue that communication going, and also we need to keep the families informed on the left side. On the right side, you see that the provider may need to talk to a specialist, or patient might need to talk to a specialist. The provider might need to talk to another nurse or another specialist, and you can see that there is some complex communication needs to be established to provide a complete solution. So in that communication mechanism, it's not one type of mechanism, not anymore. Previously, it used to be email or one type of mechanism. That has gone. So you should be able to communicate between these actors using SMS, email, telephone, and then push notification, VoIP, video, and smart devices. Siddha has provided one use case switching between different communication methods. I will briefly touch upon when I go to another slide. So moving on to this next slide, this is our solution architecture. So let's start this solution architecture from the right side. You see that Meadows enterprise application that runs within our data center. Meadows has got managed services within our data center. The provider interacts with that application. Even though it's a single box there, it's not a single application. We have multiple applications running there. You see that the provider interacts with the web application and enters some of the patient healthcare data. That healthcare data need to be available in the cloud for making that communication meaningful. So you can see that the data flows to the cloud through the streaming service at the bottom, Kafka, and it pushes that information to DynamoDB. And this data can be accessed through the Lambda through API gateway from the top. And we embed this Amazon Chime SDK and also Amazon Pinpoint and SNS to send notification to our customer, like push notification. We use Amazon Pinpoint, and Amazon Chime SDK is used for messaging services. So with that, why we selected these services, how does that fit into our stack? So first and foremost, all the Amazon SDK, Pinpoint, and SES provide secure communication, right? And we should be able to scale our services for multiple hospitals. Thousands of hospitals uses our service, so we should be able to scale that. And we are moving away from that microservices architecture to serverless architecture. This fits very well within that ecosystem, and we are able to extend our existing services to implement this solution. We don't need to implement another solution for this one. And we have established a security policy within our cloud services, and that same exact security policies can be applied to these services. Every industry has some kind of a certification or compliance, and because we are from healthcare, we have HIPAA compliance. Our services has to be HIPAA compliance. All these services are HIPAA eligible. What does that mean? We don't need to build anything on top of these services to make it as HIPAA eligible. It comes natively as a HIPAA eligible service. And well-defined SDK helps us to build web application and native mobile application easily, and it's future-proof. And I'll talk about the AI and ML services in my next slide. So you can see that this is the future state we are looking at. You can see that there are 4 boxes here. The first box is Fireworks. The second box is messaging services. That's how we have. We will be introducing AI and ML services. These are all inbuilt services within AWS. Using these services, we will be able to convert this unstructured data into structured data and extract that information and store that into EHR solution for future use. One of the use cases Sid talked about switching from or transitioning from one method to another method. I'll give an example of how we think this service is going to evolve. When provider wants to talk to some of the family members, when the patient is in the hospital, but family member cannot be with patient, but they need to establish a communication. So they get to go to our mobile app, and click on that phone number. When they click on that phone number, the provider never wants to share their phone number to the patient or family members, other family members, right? They want to keep their number private. At the same time, they don't want to carry two different phone numbers. So what we need to do is we need to convert that call as a proxy call and goes as if the call is originated from the hospital. It goes to the family member. Family member starts talking about, okay, have the conversation going, and that has to be converted into audio and video call. Then the family member would not have Meadows mobile application. May have it, might have it, or might not have it. So in that case, maybe I should remove my. In that case, the family member needs to get some kind of information from our service. So we should be able to generate a email, SMS, which will have a link to start a audio call. That link goes to that person, and that person clicks from their mobile phone, then it starts a video and audio call. That's how we see it. So that's the seamless communication between one channel to another channel, but they should be able to maintain that. And we should be able to have a native device integration with multiple devices. It's not only going to be like mobile and telephone anymore. There is smart devices coming every day, so smart devices also needs to be integrated with that service. So that's my end of my session. Even though I talked about mostly healthcare, I'm pretty sure that other industry also has similar problems, or your customer also will be having similar problems. I can tell you that using the Amazon Chime SDK, we were able to quickly build the service and provide us meaningful solution to our customer. With that, I'll turn over that to Sid. Thank you, Sid.
Thank you so much, Benyan, for walking us through your solution and your plans and where you're going. One of the things that I want to show a quick demo about, though, before we wrap up or go into a summary of what we covered today, is where we see kind of these telemedicine sessions going. And as Panya noted, the applicability is wide and broader than just simply telemedicine. We have workloads such as unemployment lines and unemployment counseling, all the way to tax preparation, to legal help. A lot of these kind of expert professional style use cases that require first asynchronous communication via SMS and chat between Pinpoint and the Amazon Chime SDK, and then escalating rapidly into telephone calls, and then broadly into actually rich audio, video, and content sharing and co-browsing style implementations that are typically required by customers. So one of the things I'd like to do is walk people through a demo, basically, of how actually these services can be put together. In this scenario, we're going to go through quickly that escalation scenario, and then we're actually going to talk about how you can use Transcribe Medical, Comprehend Medical, to basically assist the physician in filling out their chart by the contents of an audio and video session that's enabled via telemedicine and the Amazon Chime SDK. So
this is a virtual waiting room, a common requirement for telehealth experiences, as busy physicians frequently find themselves wrapping up one appointment as another begins. This virtual waiting room helps the patient confirm that they are in the right place and walks them through the check-in process. Once the doctor is ready, they can open the telehealth visit and start the video call. Hey, doctor.
Hello, Mr. Stiles. I see that you were in the hospital and were pretty sick. Let me pull up your chart right now.
Okay.
Okay, got your chart up. Were you sick and you were in the hospital?
Yeah, I was pretty sick for a while.
Okay, I see in your record, let me see here, that you had a heart attack and underwent coronary bypass surgery. Oh my. You were in the ICU for a week. I see you received some pain medication when you were discharged. Are you still taking any of those?
Yeah, they gave me Vicodin to take as needed, but I rarely take it. I only have pain over the incision.
Okay. Yeah, okay. Yeah, absolutely. Totally makes sense. I think the next step to talk about is some cardiac rehabilitation, cardiac rehab. The earlier we get that started, the quicker you'll be feeling better. You'll be feeling better. Have you been walking at all at home?
Yeah, it's been a little slow going, but I've been walking around the house a bit, just not up and down the stairs.
Okay, that's fine. Cardiac rehab will increase your strength and stamina. Then you can walk up the stairs and do your other activities of daily living. I will have the cardiac rehab nurse call you this afternoon and set up an appointment. Does that sound reasonable to you?
Yeah, absolutely. Thank you.
Okay. Are there any other concerns you have, Mr. Stiles?
No, nothing I can think of right now.
Okay, well, let's schedule another telehealth visit in 2 weeks. The cardiologist will also be seeing you regularly and manage your Lasix and blood pressure medications. I will manage your diabetes, high cholesterol, and general health. Let's just make sure that, things are up to date in your chart at your next telehealth visit. Certainly looks like we're up to date today. I will, and call my office with any concerns before then. A member of the care team will help you.
All right. Thank you.
Okay, and just remember, you can always message the care team via, just a simple text message. Okay?
All right. Sounds good.
All
Thank
right.
you.
Thank you, Mr. Stiles. You have a nice day now. Okay?
You too.
All right.
Bye.
Take care. Bye.
After the visit is completed, Amazon Pinpoint can be used to send the patient a survey, and the combination of both the Amazon Chime SDK and Amazon Pinpoint can be used to give the patient a persistent, direct connection to their doctor for follow-up questions.
So one thing I want to cover about that demo is that, just as a quick summary, what you saw there was an asynchronous session via text or chat, escalating to an audio and video session, extracting value out of that audio and video session by using Transcribe Medical and Comprehend Medical. Literally 2 lines of code basically is required to get that transcription out of that audio session. It's literally that straightforward for a developer to start getting that transcription content. Then Comprehend being used for topics analysis, figuring out what medicines were the patients on, automatically filling out their chart, eliminating some of the complexity associated with, the doctor having to type basically what they're hearing on the, from the patient. It really, Beth Israel Deaconess Medical Center, for example, has started to build, it's a hospital out of Boston, a part of the Harvard hospital system. They've actually published content on how they can basically get rid of physician fatigue by using transcription and topic comprehension to automatically fill out charts while still retaining HIPAA compliance, while still maintaining, regulatory compliance that comes with the sensitive medical field. So, and then you see that the conversation moved again back to a traditional SMS delivery mechanism that you would see with Pinpoint. Again, there's opportunities there from a API surface area to integrate things like Lex for a survey, which is what they were actually doing in this demo. You could again also start applying Comprehend for automatically determining the sentiment of the patient or how happy or what feedback they had about their particular telemedicine visit. Again, opening opportunities for that provider's practice to continuously improve from a customer experience perspective. So, just in summary, communication developer services, the category we've been discussing today, helps enable organizations to connect customers across multiple different channels, from email, as with simple email services, to SMS with Pinpoint, to audio and video and the public telephone network through the Amazon Chime SDK, through web applications, mobile applications, or maybe it's just traditional phone calls, as Panyan described, making a phone call and simply masking a provider's or physician's number is a pretty typical requirement that we see in the industry, and it's amazing how much complexity that most IT developers and engineers have to go through to deploy that problem. And now they have a secure HIPAA-compliant solution from AWS to solve that particular requirement. So we go all the way from transactional conversations to full real-time streaming audio and video capabilities. And basically, you can put these two services together to achieve an end-to-end result and end-to-end customer engagement story for your customers. We basically have, first of all, I wanted to thank you for your time today. I wanted to apologize for being late again. And I wanted to thank Pandion for his time today and actually sharing his story. MedHost is going. If you listen to this session in a virtual or on-demand form, we provide a series of links that are associated to, our GitHub repo and how to get our sample apps, including the sample app for the demo that you saw today. That was actually a live demo between me and one of my product managers, and it actually, you can replicate that result at home on demand with associated CDK and CloudFormation templates for deployment and things of that nature. So, there are some links that are available for those that will be watching this on an on-demand or virtual basis. And then we also have a series of sessions throughout the week, ranging from Chalk Talks to actual, to other deep dives on particular aspects of the communication developer services that we talked about today. These are hands-on Chalk Talk sessions. We have one specifically, for example, on the science and machine learning work that we described earlier in today's session. We also have our demo theater, AWS Village. You can talk with AWS. You can also reach me personally. I'd be happy to help. Bring you to resources as required. So on Tuesday at 4:45, we have a leadership session which talks more about the strategy and direction we are taking with enterprise business applications. I encourage you to attend that as well. Again, thank you folks for taking the time to listen to me and Pandion today. And with that, I'll open it up for questions. I know I'm running over, and I do apologize again for starting late. So with that, we can go to Q&A. Oh, I see somebody, sorry. Yes, so yes, we support the ability to actually specify what language you want to transcribe audio in the WebRTC session, on the audio session. So you can say, I want to, what shall I say, find Japanese, for example, and it'll transcribe into Japanese or Spanish. Yes, you can specify the language as part of your transcription and when you call start transcription session. Okay? Yes?
Planning to bring Alexa communication along with this service, or that's going to remain the same?
That's a good question. So Alexa communication services, there are some parts that are, Alexa communication services definitely uses AWS to power their real-time audio and video sessions today. It is a very focused application, though, around home use cases and certain areas of like how to enable drop-ins and hangouts and things of that nature between family members. I know that is something they're looking into and thinking about, is how to enable more third parties to access that Alexa device. Today you can join Amazon Chime meetings from Alexa devices. So there is an ability to actually join an Amazon Chime meeting from an Alexa device. We do have some customers who are using that today in combination with the SDK to force some of those conversations to come together. But yes, they're definitely thinking, right now they're very focused on that consumer residential use case, as you can see from the feature set, but they are definitely thinking about some of these third-party skills and how to enable more traditional get help with a business or get help for my doctor style use cases. What's next? Oh, sorry. Yeah, go ahead. That's a great question. GovCloud is on our roadmap, and stay tuned. Yep.
Are there any already built-in opportunities for integrating with, say, like Salesforce cases or any use cases you're aware of where that already happened?
Yes. So we have partners that have built turnkey, everything from video contact center style use cases associated with the Salesforce case to some of these IT help desk style use cases as well for automatic escalation. We actually have a demo on our blog channel where we describe starting a Amazon Connect chat session, for example, and us escalating to an SDK session for video and content share, which is a very typical use case for help desk. Well, similarly, that code was transplanted by one of my partners to support audio and video escalation from a Salesforce case and Salesforce chat experience. So yes, there are definitely folks who've done that work. We are looking at also, as we expand kind of our developer evangelism and outreach, we're looking at trying to put more and more examples out for Salesforce and common connectors so people can drop it in. The cool thing about the SDK is it allows us to customize that experience so enterprises can deliver exactly the right type of audio and video session or content sharing session versus clicking through into a third-party meetings application where the person watching video and sending video can do pretty much whatever that meetings application enables. So with these help desk scenarios, we can get really targeted, get really good, low friction. If you just want to do content sharing, just do content sharing, for example, style implementations. Then or if you want to dial in via the public telephone network, for example, very typical use case there. Click to call out of Salesforce. I have another partner who's built that as well. Okay, next. Anybody else? Sorry, it's very bright, so I am trying to, what shall I say, see if there's any other hands raised. Oh, yes, go ahead.
Anyone use Chime for something like drive-through services or any sort of an order point?
Absolutely. In fact, what's really neat about that is I have a customer who has done. Basically, when you drive in, it actually just dispatches a phone call to a contact center, actually, and it does dynamic call routing based upon the location of the kiosk, right? Like the thing you drive next to in the drive-through. Sorry, as you can tell, I'm not good in this industry, but it basically can detect the location. It routes the call to the right place. And it started out as a traditional telephone call because that's where the business was. But they have now started to move and escalate to WebRTC because for a number of different reasons, they wanted to enable video. But we also have customers who are starting to now integrate things like our noise suppression algorithm into these public telephone network calls so you can remove the road noise while Sid orders a quarter pounder with cheese with extra fixins. So that's what's going on there. So anybody else? And I think I got coverage. So all right. Well, if you have any other follow-up questions, I'll be off to the side. So feel free to reach out. Be happy to spend some time with you if there's anything else I can help you with. Thank you, folks, for your time. Thank you, Pandian, again for your time. Appreciate it.